War is changing quietly, not with robots marching, but with code turning human lives into probabilities. It doesn't just help commanders see, it shapes what they believe matters. Now, decisions move at machine speed until stopping becomes the exception.
Confidence is not certainty.
Is no longer just tanks and missiles. It's compute, data, and the talent writing the rules. And when it goes wrong, who's responsible? The commander, the engineer, the company, the state? Step into the algorithmic battlefield. Right now, somewhere on this planet, a human commander is staring at a screen. On that screen, an algorithm has quietly sorted life and death into neat little columns. Targets, probabilities, confidence, scores, no faces, no names, just numbers that claim to know who lives and who dies. This isn't science fiction. It's the logical endpoint of everything we've been building for decades, turning code into the invisible hand that shapes the battlefield. Before code went to war, it went to work. It learned what videos you binge at 2 a.m. It learned how to route packages, predict traffic, and recognize your face when you unlock your phone. The same techniques that decide your next TikTok clip can also decide which vehicle on a dusty road gets added to a target list. At the core is machine learning. You feed a system massive amounts of data. It looks for patterns, and then it starts making predictions. This looks like a car. This looks like a tank. This looks like a person holding a weapon. Once machines could spot patterns in millions of images faster than any human analyst, it was only a matter of time before someone asked, if it can detect a cat in your camera roll, can it detect a threat on the battlefield? Every battlefield has a history. The algorithmic battlefield is no different. It didn't start with killer robots marching across the desert. It started with something more boring and more powerful: automation. First came drones. At the beginning, they were flying cameras. Humans did everything. Humans piloted, humans watched the video, humans decided when to fire. Then the video streams multiplied. One drone became 10. 10 became hundreds. Thousands of hours of footage poured into operation centers. And no matter how many analysts you hire, there's a limit to how many screens a human brain can handle. That's when computer vision stepped in. At first, it did simple jobs: highlight vehicles, track movement, flag anything unusual. Then it evolved from help the analyst find interesting frames to tell the analyst what they're looking at. And it didn't stop with video. The same pattern spotting moved into satellite imagery, signals, radar, even social media. Instead of just asking, "What is this?" systems began to ask, "What does this mean?" Piece by piece, the human role shifted from do everything to check the machine's work. And that tiny shift is where a new kind of battlefield was born. Militaries didn't adopt AI because it was trendy. They adopted it because it solves three ancient problems commanders have faced for centuries. First, the fog of war. No commander ever has the full picture. Today, sensors are everywhere. The problem isn't not enough information, it's too much. Algorithms promise to compress chaos into clarity. Millions of data points into one dot that says, here, this matters. Second, speed. In modern conflict, reacting minutes late can mean losing units or missing opportunities. Humans take time to read, argue, doubt. Machines don't. An AI system can scan video, satellites, radio traffic, and sensor feeds all at once and output a recommendation in milliseconds. Third, manpower and cost. Training analysts takes years. They get tired. They miss things. Software scales. One model can watch hundreds, sometimes thousands of streams at the same time. On paper, it's irresistible. Less fog, more speed, lower cost. But paper doesn't bleed. Whenever we hand judgment to machines, we don't just get their strengths, we inherit their flaws. Imagine a satellite image of a city on the edge of conflict. From above, buildings are shapes, roofs, shadows, angles. A model trained on thousands of weapons depot images learns patterns that often mean military target. Then it sees something similar in a dense urban neighborhood. The system doesn't see families or classrooms. It sees pixels that match a pattern, and it flags a target. That's one kind of error, misidentification. Another is overtrust. Picture a tired commander in a long campaign facing a wall of red and yellow alerts, limited time, limited people, and a system that presents recommendations as clean, confident numbers. Those numbers feel objective, but they hide uncertainty. So when the system says, this is the right call, how often does a human really argue back? There have been cases where semi-automated systems contributed to misidentification, not because the code broke, but because the assumptions behind it were flawed. Sometimes the data was incomplete. Sometimes the model wasn't built for that region or terrain. Sometimes humans trusted the machine too much. And yet, these mistakes didn't stop the algorithmic battlefield. They accelerated it because the answer to AI got it wrong is rarely stop using it. It's almost always we need smarter code. Slowly, quietly, the role of humans in war began to change. The soldier on the hill became the operator in a trailer. The operator became the supervisor in the command center, watching AI-generated summaries instead of raw feeds. We moved from pulling the trigger to approving the strike, to reviewing what the algorithm already decided mattered. On the algorithmic battlefield, humans still wear the uniforms, sign the orders, and carry the blame. But more and more, the invisible first move belongs to code. That first move shapes what humans see, what they focus on, and which options feel reasonable. And that is real power. In this first episode, we've looked at how we invited code into the command center. It started as a helper, a way to manage the fog of war and make sense of too much data. But every time we let software filter reality for us, we give it a little more control over what we call the truth on the battlefield. In part 2, we're going to walk step by step through a modern AI-driven kill chain. From the moment a sensor sees a target to the instant a weapon is launched. We'll look at where code steps in, where humans could still say no, and how quickly that power can slip away. Because to understand the ethics, the geopolitics, and the danger, you first have to understand how code actually fights. This was part 1 of the algorithmic battlefield, when code goes to war. If this made you think, hit like, share it with someone who needs to see it, and subscribe so you don't miss part 2, Inside the Kill Chain, How Code Fights. In part 1, we saw how code quietly moved into the command center. In part 2, we're going to follow one strike, step by step, through an AI-driven kill chain. From the first pixel captured by a drone to the moment a weapon leaves its launcher, we'll watch how the algorithmic battlefield really works and count how many times a human could still have said stop. Every kill chain starts with something simple. Seeing a satellite passes overhead, capturing images of roads, buildings, vehicles. A drone circles a city, streaming live video back to a command center. Ground sensors listen for engine noise, radio signals, footsteps. All of that raw data flows into a network of machines. On its own, it's just noise, pixels, waveform, numbers. So the first job of the code is to turn noise into objects. Computer vision models scan every frame, drawing digital boxes around shapes that look familiar. This cluster of pixels, probably a vehicle. This moving shape, probably a person. This large structure, possibly a depot. The model doesn't see the way we do. It doesn't know what fear looks like, or exhaustion, or intent. It sees patterns in brightness and color, edges and motion compared to millions of examples it was trained on. From the machine's point of view, the battlefield is a sheet of probabilities. Not that's a truck, but there's a 72% chance this matches the pattern truck. Seeing objects is just the beginning. The real power and danger comes when the system tries to understand what those objects mean. Now, the code starts combining signals. Where is this vehicle? What direction is it moving? What time of day is it? How does this pattern compare to past behavior? Maybe the car was first spotted near a known weapons depot. Maybe it travels a route that's been used by supply convoys. Maybe its signature matches a certain military model. The model takes all those clues and makes a new prediction. Is this just a car or part of a military operation? This is where the battlefield becomes a spreadsheet of risk. Each object gets a threat score. Each building gets a likelihood label. Command center, barracks, civilian, unknown. The system stitches these guesses into a live map of intent. But the AI is not thinking. It's pattern matching. It's saying, in previous battles, things that looked like this often turned out to be hostile. That's useful, but it's also a trap, because the more polished and confident that map looks, the easier it is to forget how much uncertainty is hiding underneath. Once the system believes it knows what it's seeing, it starts asking a brutal question. What should we hit? This is where code moves from describing the world to prescribing actions. For each potential target, algorithms estimate three things. How valuable is this? How likely is it that we're right? And what's the predicted collateral damage if action is taken? At the top of the list, target alpha, suspected command node, mission value high, collateral risk low, confidence 88%. Below it, target Bravo, possible supply convoy, mission value medium, collateral risk medium, confidence 75%. Then the system runs simulations. Option A, Option B, predicted outcomes. And on screen, that complexity gets compressed into clean, sharp numbers. It feels rational. It feels objective. But those numbers are built on assumptions. What data went in, which patterns the model learned, how success is defined, how risk is estimated. Now put yourself in the commander's shoes. Limited time, limited information, and a system that has processed more data than any human could in a lifetime. The screen is telling you, this is optimal. You can disagree. You can say no. But how often do you override a machine that can see everything at once, while you are one tired human in a room full of pressure? Designing a kill chain isn't just about what AI can do. It's about where we draw the line between suggestion and action. Different militaries draw that line in different places. Mode 1, human in the loop. In the strictest model, the AI can detect, classify, and recommend, but it cannot act. A human must give explicit approval. It sounds reassuring. It keeps a human fingerprint on every decision, but it also slows things down. And if an adversary is using faster, more automated systems, pressure builds to push the human further out of the loop. Mode 2, human on the loop. Here, the system is allowed to act by default, unless a human stops it. That's our countdown timer scenario. The AI selects, cues, and starts the clock. The human role shifts from decide if this should happen to decide quickly if it should be stopped. Under stress, with dozens of alerts, how many clocks tick down to zero without intervention? Mode 3, human out of the loop. Fully autonomous systems, given broad rules, an area, and the ability to detect and act without anyone watching live. In theory, they follow the rules. In theory, they might make fewer emotional mistakes, but in theory is doing a lot of work. Software has bugs, data has gaps, Battlefields produce edge cases no training set can fully cover, and under time pressure, systems meant to assist can end up making the call because humans don't have time to review everything. The kill chain doesn't end when action happens. For the algorithmic battlefield, that's where the learning begins. Every engagement becomes data. Did we hit what we thought? How did the enemy respond? Were there unexpected outcomes, edge cases we didn't predict? All of it gets logged, tagged, and fed back into the system. Engineers and analysts review results, fix obvious bugs, tweak parameters. New training runs incorporate fresh data. The model updates and returns, sharper, more confident, more deeply woven into how war is fought. Let's return to the strike we started with. A drone captured an image. An AI tagged a vehicle. A system combined signals, labeled it high value, and ran numbers on risk. Now it's queued, and a timer is ticking down. At each step, a human could have said no. Someone could have questioned the initial classification. Someone could have challenged the threat score. Someone could have refused the recommendation. But the more we trust speed, scale, and polished interfaces, the harder it becomes to push back. Inside this single second is the entire tension of the algorithmic battlefield. A machine that has seen more data than any human ever will, offering a choice wrapped in clean percentages, and a person under pressure deciding whether to trust it. In this episode, we follow one kill chain from pixels to probabilities to a decision about to execute. We saw how code moves from seeing to understanding, to deciding to acting, and how humans can slide from decision makers to overseers. But this isn't just about one strike or one battlefield. There's a bigger story, an arms race to build the most powerful warfighting AI, nations racing for compute, data, and talent, companies caught between ethics and defense contracts, small players using cheap drones and off-the-shelf models to punch above their weight. Part 3, the AI arms race, power on the algorithmic battlefield. In the last century, superpowers were measured by nuclear stockpiles, tank divisions, and the size of their armies. Today, a new kind of power is emerging, measured in compute, data, and the smartest people writing code. In part 1 and part 2, we went inside the algorithmic battlefield itself, how code sees, decides, and fights. In this episode, we're zooming out. We're asking a bigger question. Who controls this new battlefield? And what happens when nations race to build the most powerful warfighting AI on Earth? Building warfighting AI isn't as simple as downloading a model and pushing it to the front line. Real power on the algorithmic battlefield rests on 3 pillars. Pillar 1, compute. That means advanced chips, massive data centers, and the infrastructure to train and run enormous models. Without high-end compute, you can't train powerful vision systems, you can't run real-time simulations, and you can't fuse sensor feeds into a single coherent picture. This turns chip manufacturing, export controls, and data center capacity into strategic assets, as important as oil pipelines and shipping lanes once were. Pillar 2, data. Battlefield AI lives and dies on training data, satellite images across terrains, drone footage from different environments, radar signatures, radio patterns, simulated enemy movement. Every engagement, every patrol, every intercepted signal becomes training material for the next generation of models. Whoever has the richest, most diverse, most accurately labeled data can train systems that see patterns no one else even knows are there. Pillar 3, talent. You can't buy this at scale in a single transaction. You need researchers who understand the cutting edge, engineers who can harden systems under stress, and operators who can use these tools without being overwhelmed. Nations are quietly competing to attract and retain this talent with funding, labs, classified programs, and partnerships with private companies. Fall behind on any one of these pillars, and you don't just fall behind in tech. You fall behind in your ability to fight, to deter, and to shape the rules of the algorithmic battlefield itself. The logic driving the AI arms race feels hauntingly familiar. We've seen it before with nuclear weapons, missiles, cyber capabilities. But this time, the weapon is code. Imagine you're leading a major power. You know rivals are pouring money into AI for intelligence, cyber operations, logistics, and autonomous systems. You don't know exactly what they have, because much of it is classified. But you know one thing, if they get a decisive edge, they might see your forces before you see theirs, move faster than you can react, and outmaneuver you at every level. So even if you believe fully autonomous weapons are dangerous, even if you worry about escalation, you still feel pressure to build your own systems, just in case. This is the new Cold War logic. If they're doing it, we can't afford not to, even if everyone would be safer if nobody did. In the AI era, the nightmare scenario isn't only a surprise strike. It's waking up and discovering your adversary's code can outthink your military at every level: frontline, networks, and crisis decision-making. That fear drives investment, and investment drives the arms race forward. There's another difference between this arms race and the last one. Nuclear weapons lived mostly inside government labs. AI lives everywhere, in big tech companies, startups, universities, open source communities. A facial recognition model can unlock your phone or scan a checkpoint. An image classifier can power a shopping app or support targeting decisions. A language model can draft emails or generate influence campaigns at scale. This is dual-use technology. The same core tools can be pointed at entertainment, commerce, or war. That puts tech companies in the crosshairs. Governments want access to cloud infrastructure, models, and engineering talent. Contracts appear for defense AI, analytics, and autonomous system support. Inside these companies, some push back, arguing their work shouldn't be used for lethal decisions. Others argue refusing won't stop anyone else. If they step away, someone with fewer scruples may step in. The algorithmic battlefield doesn't just exist in trenches and command centers. It reaches into boardrooms, ethics committees, policies, and internal debates. Decisions about deployment, access, and restrictions are no longer just business questions. They're strategic choices that ripple outward to soldiers and civilians caught in the crossfire. The AI arms race isn't just for superpowers. On the algorithmic battlefield, you don't need to dominate all three pillars to be dangerous. You just need enough code and enough creativity to bend existing tools to your advantage. Off-the-shelf drones can be modified, open models can be adapted to recognize specific patterns, commodity hardware can run decent vision and navigation without touching cutting-edge data centers. Smaller nations and non-state actors can leverage these tools for low-cost surveillance, but effective targeting support and automated propaganda and deepfake campaigns. In previous eras, advanced weapons required huge industrial bases. Today, a small group with laptops and cheap drones can build capabilities that used to belong only to advanced militaries. That doesn't mean they can win full-scale wars, but it does mean they can cause chaos, undermine stronger opponents, and make conflicts harder to predict and control. With all this investment, there's one question that cuts through everything. Does AI make war less deadly or more? The optimistic view says better intelligence means fewer mistakes. More precise targeting means fewer civilians harmed and fewer friendly troops at risk. algorithms might catch patterns a tired human analyst would miss. The darker view says faster. More automated systems create hair-trigger environments where misinterpretations escalate faster than diplomacy can respond. Leaders may feel pressure to act on warnings before they're fully checked out of fear of being too slow. And powerful AI tools can make nations more willing to take risks, believing tech will give them an edge. The truth is, AI can do both. It can prevent some tragedies and enable others. Whether AI makes war safer or more dangerous doesn't just depend on the code. It depends on how leaders use it, how much they trust it, and what safeguards they're willing to sacrifice in the name of speed and advantage. All of this adds up to a new kind of strategic instability. Traditional conflicts had visible signals before escalation, mass mobilization, troop movements. On the algorithmic battlefield, much of the action is invisible. Models being trained, systems deployed, networks probed, autonomous units prepositioned. An AI-assisted cyber operation might accidentally trigger a chain reaction in critical infrastructure. An automated defense system might misclassify an exercise as an attack and respond at machine speed. By the time humans understand what's happening, escalation may already be underway. And because so many capabilities are hidden inside classified models and closed programs, it's hard for rivals to assess true strength or build trust about red lines in a crisis. We are entering a world where code can move faster than diplomacy, where simulations can be mistaken for plans, and where the most dangerous weapons are lines of logic running on machines no one fully understands. In this episode, we looked at the AI arms race behind the algorithmic battlefield, the scramble for compute, data, and talent, the Cold War logic of we can't afford to fall behind, the role of tech companies, and smaller players using cheap tools to punch above their weight. But there's one piece we haven't fully confronted yet. When code goes to war and something goes horribly wrong, a hospital misidentified, a family killed, a crisis escalated by a glitch, who is actually responsible? The commander who trusted the system, the engineer who wrote the code, the company that deployed it, the leaders who demanded faster, more automated solutions. In part 4, we step into the courtroom that doesn't exist yet. And now, then imagine a war crimes trial 10 years from now. The prosecutor stands up and says, the system misclassified a civilian building. Hundreds died. The defense replies, the commander followed the model. The contractor followed the contract. The CEO followed shareholder value. Everyone did their job. So, who do you convict? The human who clicked confirm, the engineer who tuned the model, the company that shipped it knowing the risks, or the state that demanded faster, more efficient war? Right now, we don't have an answer. But the fight over that answer has already started. Traditional laws of war assume a human decision maker. There's a chain of command, clear orders, and a commander who can be held responsible. On the algorithmic battlefield, that chain frays. Decision making gets distributed across. Developers who train and tune models, companies that decide what capabilities to sell, military lawyers who sign off, commanders who rely on recommendations under pressure, politicians who push for faster results. Each link can say, I just did my part. And responsibility stops being a straight line. It becomes a web, and webs are very good at catching no one. Here's what makes 2026 different. This isn't a thought experiment anymore. It's a live political fight, a business dispute, and a battlefield reality. Right now, one of the most visible clashes is a contract standoff. One side pushing for the freedom to use frontier AI for any lawful purpose. The other insisting there must be bright red lines. The government's position sounds simple. If it's legal, we should be free to do it. The company's position is also simple. Legal isn't enough. Some lines can't be uncrossed. Two red lines show up again and again in this debate. No mass surveillance of a country's own citizens, and no weapons that can fire with no human involvement. And here's the pressure point. If a government wants unrestricted capability, it can threaten to cut the company out, label it a supply chain risk, and replace it with a vendor willing to say yes. That's the reality of power. The rules can get set not by law, but by contract, leverage, and urgency. We like to imagine clean systems, but real AI is messy. Every model has blind spots, every data set has gaps, and every battlefield produces edge cases no training run fully captures. Now layer legal language on top. Lawful is not the same as safe. It's not the same as predictable. And it's definitely not the same as accountable. A polished interface can turn uncertainty into confidence, and confidence into speed, and speed into irreversible harm. Outside the closed rooms, the moral argument is hardening. Major humanitarian voices are pushing for bright red lines. Ban systems designed to apply force against people directly. Ban systems that are so unpredictable, no one can foresee how they'll behave, and require meaningful human control over everything else. At the UN level, the call has been blunt. Machines with the power to take human lives without human control are politically unacceptable and morally repugnant. And the push is for a binding instrument by 2026. But here's the catch. Even as the language gets stronger, the incentives get louder. Nations fear falling behind. And when fear drives strategy, lines get negotiated down. This is the deeper problem the 2026 standoff exposes. Who actually decides how far military AI goes? Right now, power is split in an uncomfortable way. Defense agencies want maximum flexibility. Companies try to hard-code ethics into product guardrails. And lawmakers are often late, adding governance language, testing frameworks, security requirements, but rarely answering the big questions. Should fully autonomous lethal weapons be banned? What counts as meaningful human control? And who is legally responsible when a complex system fails? If the rules are set mainly by ad hoc negotiations, then the future of war gets shaped by private contracts and crisis pressure, not durable law. Beneath the legal debate is a harder question. What does it mean to keep war human? The pro-AI argument is simple. Better intelligence, fewer mistakes, more precision, fewer soldiers at risk. But the counter-argument cuts deeper. When a human life becomes a probability estimate, when a confidence score becomes the final word, you hollow out the idea that each person has inherent dignity. And even with a human in the loop, the more polished these systems become, the more humans will default to what the machine recommends and blame the machine when it's wrong. On paper, the solution sounds simple. Keep humans in control, build guardrails, write laws, sign treaties. But in practice, the hardest enemy isn't the technology. It's us, our craving for speed, our comfort with clean numbers over messy doubt, our temptation to say, the system said it was right, instead of carrying the weight ourselves. Code is already on the battlefield. The question is whether we use it to act more carefully, more transparently, more accountable, or as a shield we hide behind when things go irreversibly wrong. Tell me in the comments, where do you think we should draw the line on the algorithmic battlefield? Imagine a war crimes trial 10 years from now.